Alright, welcome back guys. So this is the second video for this lesson 6.1. We're going to pick it up where we left off after the example of uniform distributions. We are going to move on to the definition of a continuous random variable that is considered to be normally distributed. Okay. Or has a normal probability distribution if the relative frequency histogram has a shape of normal curve. The word normal, we kind of talked several times so far in the class. What it means is the curve itself. The curve itself kind of looks like a bell-shaped curve. Okay. And for a normal distribution with the parameters of the mean is 0, the standard deviation is 1. If there's any distribution that has these two things here, we call that normal distribution a standard normal distribution, and we'll talk more of that in the next lesson. What does it mean for a normal distribution to be standard, particularly? We still have this result here. Total area is equal to 1. Here's what the shape of the standard normal distribution look like here. And we know it's going to be bell-shaped curve. Okay, and the mean is right in the middle, so it's going to be 0. That's the mean. 1, 2, 3, 2, 3, negative 1, 2, negative 3. And it's kind of, so these values on the horizontal axis, that's their z-score, really, okay? And the equation for this curve here, in math, that equation is equal to e negative 1/2 x minus mu over sigma squared over sigma square root of 2 pi. Now, when we try and find the area to the left or to the right of certain z-score here, let's say we want to find the area to the left of 1 standard deviation of that, okay? So it's not same thing as uniform distribution anymore because it's not rectangle. So how do we find the area under this curve that is not in a shape that we're familiar with, like rectangle or triangle? What we can do is we can use rectangle to approximate that. We can draw this rectangle here to approximate the area of that. Okay, so we can draw a bunch of rectangle, calculate those area to approximate area to the left of 1 there. But even then, you can see that there's still some spot that we're missing there. I'll highlight that in yellow here. Alright, that is what we're missing in terms of approximation. Okay, so this technique in a higher math class in calculus we learned. This is called integration, using Riemann sum and all that good stuff. We don't need to know that advanced technique to calculate the area to the left of any variable in a stats class. All that already being done for us, meaning to find an area to the left of z-score. For example, if I want to find out, P, I want to find out the probability of a certain event happening at less than, 1 standard deviations. So this is equal to area to the left of a z-score of 1. So there's two methods to solve this here. Method 1 is use a z-table. Method 2 is use a TI calculator. Alright, so if we use a z-table, and I'll show you in that second, those area, the z-table will display all these areas that are being found using some advanced techniques that people already done for us. All we have to do is use that table to kind of look up the area itself and write down the answer. So I'll flip screen here and show you guys formula. So, for example, this is the negative z-score. Let's go to the positive score. Okay, positive z-score. So, let's say if I want to find the area, so notice that this picture shows area to the left of the z-score, so to the left only. Okay, all right. So, go back to the other example. I said if we want to find the probability of the that is less than z-score of 1, so we're looking at z-score of 1, and then there's no decimal, so just 1.0. So this is saying that area is 84% there. So if we're looking at a standard normal distribution And we want to find out what is the probability of a certain event occur that less than 1 standard deviation to the left of the mean, and that is this area there, right? So that itself is 84%. 1, 3. So all of these numbers in the middle here, these are all the area that people have been found for us using the integration technique in calculus to do that already. All we have to do is just extract these values and put down for a certain answer of certain questions. So this is one method to find the probability of continuous random variable in chapter 6. Let's go back to our screen here. For 6. Okay. Let's do the next example. Alright, so this is saying that given a standard normal curve with mu equals 0 and sigma equals 1, find the following probability or area and draw the label bell curve to support your answer. So let's say here, this is asking for the probability between z squared 0 and 1. So let's do that. So let's draw a standard normal curve. Okay, and we ask to find the probability, the area between 0 and 1. So find the probability of the z-score between 0 and 1. So that one there. Well, you know, we don't need to use a z-score table in this case to find the answer. We know that the curve is normal, so we have this rule that we introduced in chapter 3, and that is 68% divided by 2 over divided by 2. That would give us 34%, and this is just using the empirical rule. Okay, so because we know that within 2 standard deviation, that's 68. So half of it would be 34. Okay. Now let's use a z-score table well, if we use a z-score table, we would have to find the area entirely to the left of 1. So let's see if I can draw that as 2 pictures. We can find the area entirely to the left of 1 standard deviation minus the area to the left of 0. Okay, and that will give us the intersection, the middle part here. So it will probably take us longer to use a z-score table. All right, let's move on to part B. So part B, find P of z greater than 1. That means in terms of picture, we draw a standard normal curve. Here's 0 for z, here's 1 for z. Again, so the horizontal axis is the z-score. Greater than 1 mean the area to the right of 1. So this is P of z greater than 1. So area or probability z greater than 1. All right. What we can do is we can use the complement rule. Say it's the sentence 1 minus the probability of z less than 1. Okay. Well, the probability of z less than 1 is, or an event that has a possibility of less than 1 standard deviation in the mean, that one is, let's see here, I'm going to say 1 minus 68 or less than 1. So we know that this is, we know here this is 50%. This is 34. So 1 minus 84%. Oh, let me just do that again. Okay, there you go. Try that again. So that's 0.16 as the answer. Okay, I'm gonna let you guys try. Well, this one, we ran out of room. I should have given more space for this one here. This one, you want to use z-score table to look up the answer. Okay, let's go ahead and do that. Lesson 1.5. Let's go to your z table. Lesson 1.5. Where's 1.5? Let me erase all this first. Alright, let's go to 1.5 for z-score. And then no decimal at all. So that area to your left 1.5 is 93%. The answer here is 35. Okay. I'm going to pause the video here and then we'll go on the next example.